Today we learn the basis of right triangle trigonometry, okay? And you maybe remember this phrase, Sohcahtoa. I'll show you when we need to know. We're not even going to do cosecant, secant, cotangent. You just don't use them in right triangle trig. But you do use sine, and so this is confusing usually to about a fourth of the class. So let's make sure everybody understands it. First of all, we have to use right triangle trigonometry. And if you remember this, you might say, well, big deal. I'll tell you what, we will not do right triangle trigonometry for very long, just one day. And then later on, we will move to oblique triangle trigonometry, where there are no right angles in the triangle, and we'll still be able to solve them, but definitely more complex. Within this right triangle, you can see that we have a hypotenuse. Furthermore, we are referring to the angle theta, which is right here in the bottom right-hand corner. And theta makes up an angle. That angle is made up of two sides. Okay, so if you look at this angle, the angle is made up of how many sides? Two sides. Now, were you surprised that one of them is the hypotenuse? That's the longest side. But the other side is called the adjacent. Adjacent means next to. So it's the side next to the angle. It helps make up the angle. That's why it gets its name. It's the side that is not part of the angle that is the opposite, because it is across from the angle. Is that clear? Now, we use this acronym Sohcahtoa in order to write down these expressions for sine, cosine, and tangent. Sine happens to be the opposite divided by the hypotenuse, because you have O and H. Cosine is adjacent over hypotenuse, because you have A and H. And tangent is opposite over adjacent, because you have O and A. I never learned Sohcahtoa. First time I heard it, I was tutoring a student. I was helping them in mathematics. And they said, oh, we're supposed to do Sohcahtoa. And I said, what? I said, is that I thought it was an Indian word to express hypotenuse. I had no idea. I'm being honest, okay? All right? I was 17 years old, helping a student out from a different school. And they're like, you're supposed to do Sohcahtoa. I said, I don't know what that is. They're like, well, how do you know how to do this stuff? I said, well, here's how I learned it. The opposite is y. It is your vertical piece. The adjacent is x, your horizontal piece. And the hypotenuse is r, your radius. So sine is y over r. I always brought it back to the variables, and that's how I learned it. You do what you want. I don't care. So the other piece that you need to know is this. We will label the angles of the triangle accordingly. The 90-degree angle we will always call C. It doesn't matter after that which one is A or which one is B. But what does matter now is that now I have named the angles that I can then name the sides accordingly. Which side up here is going to be C? The hypotenuse will be small c. So the capital letters represent angles, the small letters represent sides. Which side will be A? And which side will be B? The adjacent. Are we clear on that? Okay, so let's try the first example. It says find the exact value of the 6 trigonometric ratios of the angle theta in the triangle. So sine of theta is equal to cosine of theta, tangent of theta. Secant, secant, and cotangent. We don't need to write the definitions because we'll never think of them like that, but once we get sine, cosine, tangent, we'll simply take the reciprocal. So I have an angle. I will draw the angle. If you struggle with this at all, draw the angle first. Once the angle is drawn, you may then list hypotenuse, because that's across from the 90-degree angle. It's also your longest side in a right triangle. And then you have your adjacent, and you have your opposite. What is the ratio of sine? Which is? Good. Cosine. Oh no. I don't know the length of the adjacent side. How will I figure that out? Pythagorean theorem. Thank you. It's a Pythagorean triple. Anybody know what it is? 12. So you got 3, 4, 5. Thank you for answering. 7's a great guess. It would be 7, 24, 25. That would work out if it was that. 8, 15, 17. You guys remember all these? Well, you don't. Why not? And any multiple of them works as well. So if you're to divide these in half, the 1.5, 2, and 2.5 works as well. So any multiple of those triples work. So there's all sorts of Pythagorean triples. We won't bore you with that. 5, 12, and 13 is 1. You don't know it, you could go like this. A squared plus b squared is equal to c squared. Really, all of trigonometry comes from the Pythagorean theorem. So we have 5 squared plus b squared is equal to 13 squared. 5 squared is 25. Subtract 25, b squared is 144. So is that my length? No. What do you have to do? Square root, you get 12. So the adjacent side is 12, so what's cosine? 12 over 13. What's tangent? 5 over 12. To get the others is super easy peasy. We just simply take the reciprocal, and we don't even have to really think about it because we are that smart. Done. Right? What do you think? No big deal, right? You do the next one on your own. Go. Notice where theta is. It's up in the corner. Careful. Okay, somebody better ask a question because I know not everybody got those. So which one do you want to look at? Which one of the 6? How do you simplify them so fast? Practice over time. So I'll show you, for example, cosecant. Let's do cosecant. First, I would do sine. And sine would be my opposite. 4 over my hypotenuse, 2 roots of 5. So 4 over 2 will give me 2 over the root of 5. And then I'll multiply top and bottom by the root of 5 to get 2 roots of 5 over 5. What's really nice is once you see that you get this as a result, you can take the reciprocal of that in order to get the cosecant right away. So, tricks of the trade, my folks, tricks of the trade. Yo. Thank you for asking. As I draw the angle, that's theta. Thank you for asking that question. That's an excellent question. There's a number of people that would choose to draw the angle here, but theta is sitting up there, so we draw the red one, not the green one. You got to draw your angle. These are great questions, guys. Anybody have another one? Going once, going twice, thrice. Keep it over. You got a better word? I think Kevin has a better word. Okay, it says solve for the missing side of the triangle. I have 9x and 42 degrees. Now, technically, there's 2 sides here that we don't know. But appreciate that in geometry with the Pythagorean theorem, you had to be given 2 sides to find the 3rd side. But right now, all we need is 1 side and an angle. So, let's do our work. I will first draw my angle, as Brooke has pointed out, right? I then identify. hypotenuse, adjacent, and opposite. The question is, which trigonometric ratio will you use in order to solve for x? Sine, cosine, or tangent? We have one vote for tangent. We have a couple votes for sine. You are given 9, and you are looking for x. So you're given the opposite. You're looking for hypotenuse. Which of the 6 has to do with opposite and hypotenuse? Sine. So we set up sine of my angle, 42 degrees. I'm going to write it over 1 is equal to what? 9 over x. Uh-oh, time to cross multiply. I get 9 is equal to x times the sine of 42 degrees. Whoop. How do I get rid of the sine of 42? Divide it off, and you get x is equal to 9 over the sine of 42. Now, for all of those of you who do not have a calculator, now you understand why it is paramount that you have one. Because I dare anybody to tell me without the use of your calculator what the sine of 42 is, correct 4 decimal places. Before you press sine, please press mode and make sure that you are not working in radians, but because our angle is listed as degrees, you go down and over and press enter on degrees. You need to understand in the test when to move back and forth between radians and degrees. Have fun. So we take 9 and we divide it by the sine of 42. And I get 13.45. Now that represents my hypotenuse, so that should be the longest side in the triangle, and it is. Let's look at our next problem. I'm going to draw my angle at 63 degrees. Which trig ratio do I use to solve for x? Sine, cosine, or tangent? Cosine, because this is the opposite, but I want the adjacent, which is x, and the hypotenuse, which is 14. So cosine of 63 degrees is equal to what? X over 14, I write it over 1 so that I have a ratio, proportion here. Multiply, I have x is equal to 14 cosine of 63 degrees. I'll show you why you need to be careful with your calculator. As you type this in, 14 cosine of 63. I press enter. 6.36. Looks great. But if I would type this differently, cosine of 63 times 14, you can see that I get negative 0.95. Which one's correct, the first or the second? Why is the second one wrong? And I did not insert my parentheses. So make sure that so that's not taking the cosine of those two multiplied together, but just of 63. So 6.36 is the correct answer. You do the next one on your own. While you're doing that, I'm going to hand out today's assignment. We do 2 problems together on that. So try to do the next one on your own. Okay, we flip from this to this. So 4.79 should be your answer for that last problem we did. We now turn to this piece. We're going to do example 1 and example 2 together. And our goal now is to solve for the entire triangle. Not just one side, but the entire triangle. I need to make sure that I put C as the 90-degree angle. Doesn't matter where you put A or B, but so that my picture looks somewhat accurate, B is 32, so I'm going to make that the smaller angle. So angle C is 90. Angle B is 32. I know that side C is 8. When it says to solve the following triangle, that means to find all 6 pieces. So can you tell me What is the easiest one to find up here? Angle A, because all three angles must sum to. So that will make this 58. All right. One down, two to go. Would you like to find side A or side B? It's up to you. A will find side A. So I'm given 8, and I'm looking for A. So we'll use sine, cosine, or tangent. If I'm working with 32-degree angle, I have the hypotenuse, and I'm looking for the adjacent. So cosine is the correct choice. Cosine of 32 degrees is equal to side A over 8. I will cross multiply and solve. I get A is equal to 8 cosine of 32 degrees. Somebody tell me what you get as a result. 6.72, 82. 6.78. How do I find A? Whoop, sorry. I ate a bowl of stupid for breakfast. 6.78. And B, how do I find B then? Yeah, you could either use sine or tangent, or you could use A squared plus B squared is C squared. 6.78 squared plus B squared is equal to 8 squared. And when you solve that, what do you get for B? That was A, 4.24. Everybody okay with that? Okay, then let's do one more. We'll make it before the end of the hour. Example 2, what's different? There's no angle. I know angle C is 90 degrees. I know side A is 5. And I know side B is 12. But I don't know either of the angles. What is the easiest part to identify right now? Side C. How would I do that? Pythagorean theorem. We've already done an example like this. We would figure out that C is 13. Now I have to find two angles. I'm going to write down that C is 13, B is 12, and A is 5. You tell me, would you like to find angle A or B? Okay, we'll do A. Which trigonometric ratio would you like to use? Sine, cosine, or tangent? Doesn't matter. Okay, Caleb picks sine. And we're going to write then the sine of angle A is equal to what? 5 over 13. So what that means is our variable is in the angle instead of over on the other side. How that changes things is if you are looking for an angle, you don't press sine, you press second sine. That's called sine inverse or arc sine. And you don't type in the angle, you type in this value, and it will give you the angle. 22.62. Is it now easy to find B? We subtract from 90, and we're going to get 67.38 degrees. So your assignment will be to complete this worksheet and solve the triangles. But all of the ones that are odd on this side, on the left side, you will be given an angle and a side. All the ones on the right-hand side, you'll be given two sides, and you'll have to find the missing angles as well. All right? I will hand you the study guide as you walk out the door.